Hey, good day, grade 8. Welcome back. So in the last lesson we spoke a little bit about special angles and supplementary and complementary angles. Okay, so today we're looking at proper geometry. We're getting into it. There are a lot of theorems that you need to learn. Okay, so today we're only going to do the first three. But before we get started, I just want to give a little bit more emphasis on the reasons and on how you set up your answer. Okay, so reasons are incredibly important. I'm going to write here, for every statement that you make, a statement is just what we call an equation in geometry. Okay, so every time you write down an equation, so for every statement, which is just a way of saying equation, you need a reason. You need to tell the person who's reading your work or who's marking your work how you knew that statement was true. And it's not because ma'am told you, okay? It's because somebody figured it out once upon a time back in the olden days and they came up with their reason and you use their reason. Okay, it has to be the reason that I show you. Okay, so for every statement you need a reason, and the way you're going to set up your geometry calculations is as follows. It's got to be exactly like this. Okay, you write your statement or your equation. Okay, if you know you're going to get confused with what statement means, write down that it means equation. Okay, so you're going to write your statement. Next to your statement, leave a bit of a gap, so further to the right or in the middle of the page, you're going to put your reason in brackets. So you saw this with Pythagoras, hey? With Pythagoras you would write down hypotenuse squared equals side squared plus side squared, and then in brackets you would put Pythag. Okay, so same thing. Your equation or your statement, your reason, and then underneath your statement you then go ahead and solve the equation. Okay, which obviously will take up as much space, as many lines as you need. But basically it's equation, reason, and then you solve your equation. Okay, now today the three theorems that we're going to look at. A theorem, by the way, is just it means the same thing as a theory, except it's one that can be mathematically proven. Okay, so a theorem is sort of just a law in maths. Okay, and the theorems we're looking at today are the theorems that talk about the angles that make up our special angles. So just a quick reminder, if I can find the page, there we go. In the last lesson we looked at these special angles. Okay, specifically the ones we're going to look at today are the angles that form a right angle, a straight angle, and a revolution. Okay, because these are the ones with specific values. All right angles are 90, all straight angles are 180, and all revolutions are 360. So we're going to look at angles that form these three types of special angles. Okay, so angles that form special angles. I don't know why I'm out of breath. And the first one we're looking at is angles that form a straight line. So when I say form a straight line, I mean angles that when you put them all together make up a straight angle or make up a straight line. Okay. So when we have angles that make up a straight line, the rule is that angles that make up a straight line add up to 180 degrees. Okay. Angles that make up a straight line add up to 180 degrees. And remember in the last lesson we learned a fancy word that means adds up to 180. This is supplementary. Okay, so another way of saying this rule is angles on a straight line are supplementary. Okay, so to see this graphically, let's draw ourselves a little diagram. If I have a straight line, okay, there's my straight angle. There's 3 points. So there's my one arm, my middle point, the vertex, and then my second arm. If I take this straight angle, have I got a pencil? Yes. Okay, we know that that whole thing is 180 degrees, right? So if I take that whole thing, and let's say in the question they split it up. They've put another angle over here. Let's call this angle A. And they've put another angle or another line over there to split this into angles B and C. Then logic dictates, and you should know this, you should be able to make this step. If you have something of a certain size and you split it into bits, if you then put those bits back together, you should get the same thing you started with, right? So if I have a straight line and I've split it into 3 angles, then those 3 angles together should give me a straight line, and we know that a straight line is 180 degrees. So that's basically what this theorem is. If I have a straight line and I split it into angles, those angles together must add up to 180 degrees. Okay, so the way you would set up your answer if you were given a question like this is you would say this angle plus that angle equals 180 with a reason, and then you might solve for one of them. Okay, so they might give you that that's 10, that's 30, and then you must solve for this one. I will do examples. Okay, so this theorem mathematically says that this angle A plus B plus C will equal 180 degrees. Some of you might be a bit concerned now because I'm not using uppercase letters. I'm not using the naming that we used in the last lesson. Remember, uppercase, capital letters are the names of points. Lowercase letters are variables. Okay, so this A could be a value. It's the value of the angle. It's not the name of the angle, it's the value of the angle. Okay, so it's A plus B plus C equals 180 degrees. And now our reason, very important. You know all your reasons off by heart. Our reason, if we ever use the fact that we know that angles on a straight line add up to 180, is angles on for straight, I can't fit in my reason now, line. Okay, angles on straight line. Nice and abbreviated like that. You don't write out the whole sentence. It's just angles on line. Okay, and you need to learn this reason off by heart. You need to know it. Very important. Okay, next theorem. That's it. That's our first theorem. Next theorem is angles that form a right angle. Oh, this is going to annoy me. Everything to do with straight lines was blue, and now I've made that a green cloud. Sorry. Make it a blue cloud. Okay. Next one, angles that form a right angle. We're using the same logic. Okay, angles that form a right angle will add up to 90 degrees. If we've got angles that form a 90-degree angle, obviously that means they will add up to 90 degrees. And also remember in the last lesson we learned the fancy word that means add up to 90. That is complementary. So we can also say that angles that form a right angle are complementary angles. Okay, and again we're going to draw ourselves a little diagram to show this. So if this is our 90 degree, okay, there's our 90 degree. I've lost my pencil, there it is. Okay, if I take my 90 degree and I split that up into angles, and I put all those angles together, then they will form a 90 degree. They will add up to 90 degrees. I nearly said 180. Okay, so if I took this 90 and I split it into two parts like this, an angle of x degrees and an angle of y degrees, then my x and my y together must give me that 90. Okay, so mathematically this theorem says that x plus y will equal 90 degrees. And again, we need a reason. Oh my goodness. I hope that doesn't interfere too much with the audio of the video. I don't know what they are doing outside. Okay, so x plus y will add up to 90, and our reason, nice and easy, right angle. Okay, so your reason is right angle. Our angles add up to a right angle. Again, you need to learn this off by heart. Please, you have to know your reasons. Okay, and there's only one more theorem for today. Our last theorem is angles that form a revolution. And again, we're using the exact same logic. Okay, if we have a full revolution and we split it up into angles, then all those angles together must add up to 360 degrees. And there's no fancy word for 360 degrees. Okay, so let's draw this. Remember, if you have a revolution, it sort of just looks like a lollipop. Okay, a single line. It's one line that went all the way around back to where we started, hey? So the path that it went was all the way around. So that would be our 360 degrees. But if we took that and in the diagram they've split it up into, let's say, an angle there, and let's say, where should we put the last one? Down here somewhere, an angle there. Okay? They can split it up into more than 3, by the way. They can split it up into 7 if they want to. I'm just in these diagrams splitting it up into 2 or 3. Okay, so let's say they split it up into that angle X, this big reflex angle Y, and this little acute angle Z. Okay, then that means that all 3 of these angles together, if I go from here, X, Y, and Z together, I get back where I started. So that adds up to 360. Okay, so here the angle of X degrees plus Y plus Z will give me 360 degrees. And our reason, this one's a little bit trickier. It has nothing to do with revolution. Please don't write revolution as a reason. It will not be marked correctly. Your reason here is angles round a point. Okay, so angles round a point. And you need to, once again, learn this reason off by heart, please. Make sure every time you use the fact that you know angles around a point or angles that form a revolution add up to 360, your reason is angles round a point. Okay, let's get to some examples. Question 1. Here's our diagram. We've got a straight line AC through the point B, and then another line BD meeting there at that point B. They've told us that this little angle here is 30 degrees, and they want the size of angle ABD. So let's look, where is ABD? Okay, so B is the middle, so we look B, it'll be an angle formed at B, and it's formed by the lines AB and BD. There's our angle ABD that we're looking for. Okay, now looking at this diagram, we can see that ABC is a straight line, right? And we know that together these 2 angles should make 180 degrees. That whole angle should be 180 degrees. Okay, so we're going to use the fact that we know these 2 angles must add up to 180. So we write down our statement. Remember, when you do geometry, it goes statement, reason, solve equation. Okay, so we're writing down our statement, which is that this angle we're looking for, angle ABD, plus that little angle there, 30, must add up to 180 degrees because they form a straight angle. Okay, and our reason, angles on stir line. Okay, angles on a straight line. And now we solve for ABD. This is a nice easy equation. Okay, we hop our 30 over and subtract it, or additive inverse if you learned it that way. Okay, subtract 30 from both sides. And we'll get as our final answer, ABD equals 180 minus 30 is 150 degrees. Okay, and that's it. That is your answer. For a question like this, it would be worth 2 or 3 marks. Okay, if it's worth 2 marks, it'll be 1 mark for your statement and your reason, and 1 mark for your answer. If it's worth 3 marks, it'll be 1 mark for your statement, 1 mark for your reason, 1 mark for your answer. So see, if you leave your reason out, you lose a fair number of your marks. If you do it for every question, you'll lose at least 1/3 of the whole paper's marks, just for leaving out your reasons, or getting them wrong. So please make sure you learn these reasons off by heart. It's not often in maths you have to learn off by heart. So go ahead and learn the reasons off by heart, please. Okay, next one. Find the values of x and y. Okay, find the values of x and y. So, a little bit tricky one. So we can see that we've got a straight line going down, right? All of these together must add up to 180. But if I go and write that as an equation, my equation will say y plus 45 plus x plus 50 equals 180. Then I've got an equation with y and x in it. We've never done something like that, where you've got 2 different variables in an equation. Okay, you cannot solve an equation if you've got 2 different variables in it. So we're not going to go ahead and do that right now. We first have to find the value of one of these, x or y. Then we can go and do angles on a straight line. Okay, so let's see what else can we use. Well, we've got a 90-degree angle there, which tells us that this y and that 45 must add up to 90. There we can make an equation with only 1 variable. So So we're going to start with that. We're going to start by saying y and 45 must add up to 90 degrees. Okay, why is that? Because I have a right angle. They told us that this was a 90-degree angle. Okay, remember, you always need your reasons. And now we solve for y. So we're going to hop our 45 over and subtract it. I forgot my degree, sorry. And we're going to find that y equals 45 degrees. Now, in a scenario like this where you've got multiple variables in one diagram, my suggestion, I highly suggest this because it's going to get more and more and more confusing, your diagrams, is as soon as you find the value of something, go and write it in on your diagram. So this is now no longer y, it's now 45. We've worked it out, it's 45. Okay, now we must still find x. Now we can use the fact that these four angles all make 180, because now it's 45, 45, x, and 50. I only have one variable, so now I can solve that as an equation. Okay, so I'm going 45 degrees plus 45 degrees plus x plus 50 degrees must give me 180 degrees. Okay, how do I know that? Not because ma'am says so, but because I have angles on a straight line. Okay, angles on a straight line must add up to 180. And now we solve for x. Okay, so we're going to hop over our 45s and our 50 and subtract them. So we're going to have x equals 180 minus 45 minus 45 minus 50. And we're going to get 40 degrees. X is equal to 40 degrees. Okay, so notice how I've set these up. Equation, reason, solve the equation. Equation, reason, solve the equation. So this question would be a 6-mark question. Equation, reason, solve. Equation, reason, solve. Okay, 3 marks for y, 3 marks for x. Okay, question 3. Where did I put question 3? Sorry, there it is. Okay, here is our question 3, getting slightly trickier as we go along. So we need to find the values of the letters A and B. So A is this angle here. Okay, it's being formed there by those 2 lines. B is this angle here being formed by these 2 lines. Okay, so we've got to find the values of A and B. What are the sizes of those angles? Okay, now, again, we could go ahead and do angles around a point, or angles, yeah, we could, okay, so we could say A plus 90 plus 30 plus B plus 30 must give me 360. It goes all the way around. But then I would once again have an equation with A and B both in there. And we can't solve an equation that has 2 variables in it. Okay? You can only solve an equation with 1 variable. So we have to try and focus on A and B individually at first. Okay, let's start by looking at A. Do you see that A and 90 together form a straight line? If I just ignore that whole left-hand side of the diagram. Okay, if I just look at that side of the diagram. And don't worry, if you didn't see it immediately, the more you practice this, the easier it will become to see them. Okay, so we can see that that whole thing is a straight angle. That must form 180 degrees, which means these 2 angles are supplementary. They must add up to 180. Okay, so we're going to go ahead, write down our equation and solve it. A plus that angle there, which is a 90, right? Little blocky means 90, so A plus 90 will give me 180 degrees. Our reason, angles on a straight line. Okay, we knew they added up to 180 because together they make a straight angle. And we solve for for A, and we'll get that A equals 90 degrees. We subtract 90 from the right-hand side. Okay, so we found A. Remember, as soon as you find something, you're going to go and put it in on your diagram. So A is now no longer A, it's now 90. Okay, and now for B. So some of you might be looking at this and thinking, ma'am, we can do the same thing we did, but on the other side. We can ignore the right-hand side and look at this. That's 30, B and 30 add up to 180. That's perfectly fine. You can do it like that. I would personally do it like that if I were writing a test, but I just want to show you that there's another way of doing it. We can also look at this diagram and see if I start over here and I go all the way around, 30, B, 30, 90, and 90 together must all give me 360 degrees. We can also solve it that way. Okay, it's a bit of a longer one, a little bit of a tricky equation, but I just want to show you that that is also a possibility and you'll get the same answer. Okay, so we're going to do it that way. So we're doing 30 degrees plus B plus another 30 degrees plus 90. Remember, that's not A anymore, now it's 90 degrees plus the last 90 degrees must all together give me 360 degrees. And I've run out of space for my reason. I'm just going to put it under here. Angles round a point. Okay, I used the fact that all the angles that make up a revolution add up to 360, and your reason for that is angles round a point. It's basically saying I've got a point and I've gone all the way around it back to where I started. Okay, the angles all the way around a point add up to 360. And now we solve for B. So we say B equals 360, and we subtract all of these values from the right-hand side. So minus 30, minus 30, minus 90, minus 90. And we get B equals, that's 360 minus 180 is 180, minus 60 is 120. So B is equal to 120 degrees. Okay, just a little heads up, looking at this diagram, some of you might have looked at this and said, ma'am, that's 90, that looks like 90 degrees. You could maybe even measure it with your protractor and say, look, it is 90. Okay, no. Hear me nicely now. No. You do not look at something and say, it looks like, therefore it is. Absolutely not. In geometry, your diagrams are never drawn to scale. Okay, if I give you this diagram and I tell you that's 90 degrees, you don't say it doesn't look like 90, you say, yes ma'am, that's 90. Okay, in a test or an exam, they will label it if you are meant to know the size of the angle. They could label this as 90, you just accept it. Okay, they could give you this and tell you that that angle there is 20 degrees. Doesn't look like it, but you accept it. Got it? You never look at it and say it looks like. You look at it and say, is it labeled with a value? That's the only way you know the size. Okay. Question 4. We're going to find the value of x. Okay, now we start panicking and hiding under our bed again because we see we've got lots of letters. Please do not. Now remember, up until now I've been saying we cannot have an equation with more than one variable. Well, x, 2x, 3x, it's all the same variable. So this we can have an equation. Okay, because it's the same variable, it's like terms. And we see that these are all on a straight line. They must all add up to 180 degrees. Okay, so let's go ahead and solve. We write our equation, our reason, and then we solve our equation. So our equation here is that these three angles add up to 180. So it's that angle x plus that angle 2x plus that angle 3x must all give me 180 degrees. Why? Because they are angles that make up a straight line, hey? Angles on a straight line. Okay, and now we solve for x. All of my x's are already on the left, so I don't need to move any terms. So I'm just going to go ahead and add like terms. Remember, x is 1x. That's a 1x. So I've got 1x plus 2x plus 3x is 6x. And I'm hoping you remember this from equations. To get rid of the coefficient, we don't want to know what 6x is, we want to know what x is. So to get rid of that 6, we divide both sides by 6. You divide both sides by the coefficient of x. And we get those x's cancel, which is why we did it. That's what we want, to have just an x. And then on the right-hand side, 180 divided by 6 is 30. Is that 6, 12, 18? Yes, 30 degrees. Okay, so each one of these x's is 30. So actually now, just for fun, let's see what the sizes of the angles are. So x, this angle is 30, right? This angle here is 2x, 2 times 30, so this angle would be 60 degrees. This angle here is 3x, so that's going to be 3 times 30, 90 degrees. So see, this does not look like a 90 degree. But guess what? We calculated that it is, therefore it is, even though it doesn't look like it. Okay. Okay, and last one here is question 5. Determine the size of angle DBE in terms of x. Let's first identify angle DBE. Okay, B, the copy is on the B, which means the angle must be here by B, and it's formed by lines with a point D on it, so it's D, B, and then the line with E on it, E. So here is our angle. Angle DBE is the angle we're looking for. And now this looks a little bit scary. In terms of x. Okay, you did look at this when we did space and shape. You had to do area, perimeter, volume, total surface area, sometimes in terms of x. Remember, in terms of x just means your answer will have x's in it. You're not going to have a numerical answer, you'll have an algebraic answer with an x in it. Okay, so here, angle DBE, angle x and angle 2x, all together form a straight line. They must add up to 180 degrees. Okay, so x, I'm writing down what I'm thinking. X, my angle DBE, and 2x all together must make up 180 degrees. How did I know that? Because there are 3 angles that form a straight angle. They are angles on a straight line. Okay, and they want the size of DBE in terms of x. So that means DBE must be by itself on the left. On the right-hand side must be everything else, including x's. Okay, so I'm keeping my DBE here where it is. That's staying. My x and my 2x need to ballet go over there to the right-hand side. Okay, we've got to chuck them over to the right. So I'm keeping my DBE on the left. Angle DBE is staying. And on the right, I'm going to have my 180 degrees that was there. And then my x and my 2x are coming over. Okay, and then always just make sure that you have simplified it as far as you can. So 180 is not a like term with x and 2x. So 180 we can't subtract or add. But negative x and negative 2x, those are like terms. You can simplify that. Okay, so we can simplify this to angle DBE equals 180. We can't touch the 180. And negative 1x minus 2x is negative 3x. Okay, and we are done. That is the answer. I know it looks a little bit unneat, it looks a little bit gross, because it's still basically a sum, an expression, but we have done what they've asked. They've asked us for the size of DBE in terms of x. We have done that. Okay, so we are done. We are happy. We are finished. Okay, and that's it for this lesson. Next week we're going to look at the slightly trickier types of questions. Okay, we're going to look at the other theorems. I think we're going to do vertically opposite angles, some triangles, and some parallel lines. Okay, guys, good luck. Enjoy. Get in contact with your teacher if you get stuck. Get in contact with me if you want to as well. Okay, have a lovely day. Bye.